your cooperation and consideration.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to guest lecture series on SDGs today, Tuesday, 26 October 2021. I'm Vivian Anggani from ITS Global Engagement and will be your master of ceremony this afternoon. Thank you for joining our guest lecture series on SDGs today. Before we start our agenda, let me inform you some rules for the event. To the participant, first, please adjust your name or ID screen using format name_campus. The second, during the lecture, please turn off your microphone and only turn on the microphone when the moderator gives the chance. Third, please fill your attendance at bit.ly/GLS_attendance. And our committee also sent the attendance link to the Zoom chat room. For the participant who wish to get a certificate and stamp for it, please fill the attendance 15 minutes after the session starts. Fourth, the participant who wish to ask question during question and answer session, please send your question to the bit.ly/GLS_Q&A. The link question listed in the Zoom chat room as well. Or you can ask directly by clicking the raise hand feature. Today's GLS on SDGs will present a topic entitled How Artificial Intelligence Will Change the Future, that will be delivered by Associate Professor Najib Yasin from University Malaysia Perlis. Other than that, we will also have another lecture, the title The Swarm Intelligence in Communication Engineering, that will be delivered by Dr. Khairul Najmy Abdul Rani from University Malaysia Perlis. And this lecture will be moderated by Dr. Raras Maya Indraswari from Institute Technology 10 November. Before we start our agenda, allow me to deliver our schedule today as follows. First, we will have the opening. Second, introduction to moderator and speaker. Third, we will have the lecture session. Fourth, question and answer session. Fifth, certificate awarding, and sixth, we have closing. Now, before we proceed to the agenda, let me introduce you our moderator today. Our moderator today is Dr. Raras Maya Indraswari from Institute Technology 10 November. Dr. Raras Maya has graduated in doctoral degree in computer science at ITS and also has a bachelor degree in informatics at ITS. She has work experience as a lecturer at Information System Department, and also Dr. Raras Maya is the member of Data Acquisition and Information Dissemination Laboratory. Dr. Raras has also has research interest in data mining, artificial intelligence, machine learning, deep learning, imaging processing, and also computer vision. Dr. Raras Maya has also achieved some rewards as follows: Best Presentation Award 10 International Conference on Soft Computing and Intelligent System in 2017, and the second reward has received the Best Paper Award in 4 International Conference on Informatics and Computing in 2019, and the third reward that already achieved by Dr. Raras Maya is Best Graphics App Tiger App Web App Hack in 2021. Now, without further ado, let's proceed to the agenda. To Dr. Raras, the time is yours.
Thank you very much, Ms. Vivi. Good afternoon, ladies and gentlemen. My name is Raras Maya, and I will be the moderator for today's event. We are welcoming all of the participants of the guest lecture series on Sustainable Development Goals, or SDG. This event is held by the ITS Global Engagement, and today's topic is about artificial intelligence, which is related to the 9 SDG, industry, innovation, and infrastructure. We will have 2 honored speakers in this seminar. Both are from University Malaysia Perlis. Welcome, Dr. Mohd Najib and Dr. Khairul Najmy. Thank you very much for coming. Today, we will have 2 lecture sessions. The first session will be given by Dr. Muhammad Najib with topic How Artificial Intelligence Will Change the Future. And the second session will be given by Dr. Khairul Najmy with topic Swarm Intelligence. Each lecture session will take at maximum 40 minutes. And after that, we will have question and answer session for both of the sessions. The participant can write their question in the chat box during the session, or raise their hand and ask the question directly to the speakers on the Q&A session. Okay, now we will enter the first lecture session. Let me introduce the first speaker. Dr. Muhammad Najib Muhammad Yasin is from University Malaysia Perlis, and also he is the head of COA Advanced Communication Engineering. Dr. Najib obtained his Diploma of Engineering degree in Electronics from University Technology Malaysia on 2003, and then he obtained his Master of Engineering degree in Electronics from University of Sheffield in 2007, and then he obtained his PhD degree on Electrical Engineering, University of Sheffield on 2013. He is also the Chartered Engineer from Engineering Council UK and graduate member of Board of Engineers Malaysia. His research interest is about the electric resonator antenna, wireless power transfer, wearable antenna, circular polarization, antenna design, MIMO, IoT, RF circuit, UWB antenna, and 5G antenna application. Oh, very interesting, isn't it? So please, let's begin the first lecture session that will take at maximum 40 minutes. Please welcome our speaker, Dr. Muhammad Najib. Dr. Najib, the time is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Can you see my screen now?
Assalamualaikum warahmatullahi wabarakatuh. Yeah.
Okay. All right. Thank you, all the participants today. I'm very happy to give lecture today to all the students. Okay. As we see the title for this speech is about how artificial intelligence change the future. It's a good thing to know about the artificial intelligence now, because it seems that these topics have been raised up. It's been attracted by, if you know, the most of the major companies, just like Apple, Google, Facebook.
Rapel. Sampean ini agak apa-apa. Aku, iya, kalian.
Ya, tidak kedengaran.
No, please continue, Dr. Najib.
Okay. All right. Sorry, if any problem, just let me know. Okay. Okay. We have this topic to be shared previously today. We have the overview of AI, in between keywords, machine learning, supervised learning, what is the tools available, and what's next. We will have some basic understanding of the machine learning today. Okay. So, okay. Before we talk about it, if you don't understand or I'm talking too fast, you may let me know. I will try to slow down my voice or my tone. Okay. All right. So where it begins is very important. Before we go into further, we need to dig to the previous history, which how AI was born, and this is what we call it the first things that comes to mind when I want to talk is about the industrial revolution. And we can see from the screen, we have at the 18th century, we have the industry 1.0. All right. So first of all, what is the industry 1.0? Actually, previously, before we have the existence of industry 1.0, we use the animal, just like cow in the farm, in the agriculture. We use the animal as a transporter. We use all the many mechanical things as a transporter. We are not using any machine yet. So that's how we define as before the age of industry 1.0. We use the animal as a medium to help us on our even our agriculture, in the agriculture, in the farming, or in the transportation, or whatever media we use. Okay, and then it starts 1.0. How is different between 1.0 and 2.0? As you can see, 1.0, all the equipment usually powered by steam. So they use a scheme. We know that previously how they use the scheme. They introduced the car. They introduced the factory. Introduced many machine using this scheme. That was the first one. And the Industry 2.0 started at 19th century, right? Early 19th century, where they have the mass production assembly lines requiring the labor. Now they are using the labor and the electrical energy. And not only the electrical, but also they're using the charcoal, right? So what is it? So they changed from the steam toward the electric, okay? And the third, IR.0, they started to using the automated production using electronic and IT. So Industry 3.0 in the 20th century, it means that they start using the robots. And that's the difference between the 2.0 and 3.0 automatic. So what is 4.0? All right, this is how the artificial intelligence kick in. Right, there are several there are more, but more key enablers for the IR 4.0. All right, IR 4.0 is the combination, right, of the robotics, of the AI, of the IoT, of the cloud technology and big data. So these are the things, are the key enablers for the IR 4.0. It means that those robots must equip with IoT, must equip with artificial intelligence, must equip with big data and everything. So if they use these key enablers, one of these key enablers, so it means that there's change to 4.0. Okay, so what is the artificial intelligence? Okay, so this is what the important things that we need to know. Okay, so it's actually the artificial intelligence, as you can see from the slides, the central problems of AI include reasoning, knowledge, planning, language, perception, and the ability to move and manipulate text. All right, so actually artificial intelligence in the easiest way is a brain, right? It just work as a brain. How is going to work as a brain? That's the most important thing. Okay, so we will discover later how this artificial intelligence will work as a brain. So if we have this artificial intelligence, it means that previously the automatic robot, right? If you can see the 3.0, we have the automatic robot. But the automatic robot, what's the difference between AI and the automatic robots? All right, automatic robots only manage to do the one that we only program to it. For example, we want it to walk towards the building, for example, the robots, right? So they only manage to walk towards the building. How about if they have some resistance or they have some block at the middle during the robots towards the building? So the robots doesn't know about it. So they will try to crash the obstacle in front of it. But in the AI, if we install the AI inside the robot will know that there have some obstacles in front of him. So what's going to be? So it will try to use another way to prevent it from crash. So it goes to the other side. So how is it going to happen? That's how the AI play part. Okay, so that's very easy way to understand the AI. So AI is we teach the machine to learn how to do something work. And if there are something that unpredictable things, they need to make the decision by his own, right? Okay, that's how we understand what the artificial intelligence. Okay, so anyone who don't understand, we can ask me later, that I will try to simplify it. Okay, so okay, what's the overview of AI? What's involved in intelligence? Okay, ability to interact with the world, speech, vision, motion, multiplication, ability to model the world and to reason it, ability to learn and to adapt. So it means that what is intelligence? It means that it can do anything, right? It can do all the things that human can do. That's the robots can do. If you remember, there's some movie called AI Robots. iRobots. I think it was cast by one of the famous, I'm not sure what is it. Will Smith. If you know Will Smith, you know the film, you can watch it. That's how the iRobots played, how the AI kicks in, and how after that you will see that iRobots will take over the human, and they have a war on that. That's how the vision of the producer at the time towards that movie. So that's the I can't say Is it true that iRobots will take over human and will have war, everything? We're not sure about it, but there are some very good on the talk about it as well. Maybe and maybe not. So these are the things that it is very interesting. And if you are managed to learn about this artificial intelligence, I'm sure your market is not only in Indonesia, not only in Malaysia, but you are going to go beyond that internationally. Okay, so all right, what's going in AI? Okay, later on I will introduce you some of the videos. What are the use of AI in certain sectors? That's most important thing. Okay, so to build the system that exhibit intelligent behavior, right? So it means that what? It means that it tries to replicate the brain. That's how what we call the intelligent behavior. And then to understand intelligence in order to model it. So we need to understand the intelligence in order to model it. Okay, I think we have some videos here. I can play it. All right, you can see this one.
Excuse me, Dr. Najib, is
Yes.
the video should have sound?
Not yet.
Oh,
Not
okay.
yet. 1 second. I think. Oh, they cannot see it yet. I think there is no. You can't hear anything, right? It's okay. It's okay. Never mind. I move. Later on. I will share that. Okay. So a brief of AI history now. So in 1943, right? Bullock and Pitts proposed model of artificial neurons. Right. It starts from neurons. Right. So 1956, Minsky and Edmonds built first neural network computer and the SNRAC. Okay, you can see this one. This is the first one. Okay, the first neural network. Okay, and you can see that in 1956 as well, the John McCarthy organized a 2-month workshop for researchers interested in neural networks and the study of it. At this time, most of the studies of AI, we call it neural network. Okay. Agreement to adopt a new name for this field, artificial intelligence. Then they start to call it artificial intelligence. Okay, so 1952 and 1969, Arthur Samuel Checkers player, Shaky the robot, lots of work on Rollingwood. So he's the one who are doing a lot of research on the neural network and the artificial intelligence. What he said that initially when he developed the checkers playing program, you know the checkers game, right? We call their checkers. Arthur was better than the program, but over the time, the checkers playing program learned what the good board positions and what were bad board positions, and are playing many games against them. What is it meant? Okay, maksud dia. Alright, what it means actually at the first initial, the author is better than the programmer, right? But as it learns towards the what is going to be the bad move, what is going to be the good move, they learn it towards time, right? Just like human, you learn it towards time. And at certain time, when they have the training, after they finish the training, so the machine become better than the human. Okay, so AI appeared 1966 and 1974 is AI problems appear to be good, too big and too complex, right? So it means that as what you can see from this is the introduction of computers, right? At that time, computers are very slow and very expensive and have little memory. It means that it cannot store a lot of information because of this memory, what we call it, little memory compared than today, right? At that time, and it's very, very expensive. All right, 1969, 1979, knowledge-based system, birth of expert system. And the idea is to give AI a lot of information to start with. All right, 1980 and 1988, all right, R1 become first successful commercial expert system. Some interesting phone company system for diagnosing failure of the telephone system. It means that what? It means that this AI has been used to detect any failure in the telephone system at the time. Okay, so that's how we use it. 1990s to the present. increase in computational power. So computers become cheaper, faster, and have tons of memory than they used today. They used to be in the previous day. So example, if personal is computer chess. Okay, so we can see that in 90s to present, we know how the computers have been risen up. You can see from Apple Macintosh, and now we have the MacBook Pro. Latest I think this month we have the latest one, the M1 Max and M1 Pro for the processor. What is this all about? Why we need to have certain good processor memory? This is good for many programs, and especially in AI. It means that with the introduction of very lot of core in the processor, it means that it have more ability to think more than human itself. So you just imagine they have a billion of transistors in one single processor for the M1 chip, for example. And M1X, they have more than 16 billion of transistors. Just imagine that. So when you say about billions, so it can say that it can manage to do a lot of things. All right. First of all, I'm saying that why this AI is very important. Why not just let the human doing it, right? Why not we have a lot, for example, in Indonesia, we have a lot of workers. We have a lot of students who are going to graduate, and surely they will fill they will employ. So why we need these machines? Okay, the only things that the best of machines do is the repetition. Human hate repetition. I mean that, okay, for example, I'm saying that you are now in the first year of your studies, right? If I said that next, because of this pandemic, your studies need to extend 2 years. I mean that next year also you're going to have another, you're not going to go to second year, but still in the first year. And the third year as well, you're not going to the first year as well. So what people will do? People will become bored. How many days that, how many years that we need to finish our studies? You might think about it. Or if, for example, if you are in a factory, you are doing in a manufacturing task, you are doing this to do the simple things, but repeated every single day. You repeating, and you become bored. What happened to the quality of it? At the first time, maybe you have my very good quality, but at the peak of maybe like 7 months or 8 months later, you become bored, and your quality is dropping. So you don't have any interest. Human play motivated by their interest, right? So if they don't have any interest, they will do that. So the AI is managed to do this repetition it alone, billion of times, many of times. They do not say that I don't want to say it, stop it. Because why? Because they don't have this kind of board or any feeling towards their works. That's why AI play important part, especially for the companies in order to develop or grow. And these countries, any countries in the world, will need AI. Trust me. Even the countries now are using AI to win the elections and in the politics and all that. So the AI play big part of that. Okay. All right. So where we see that this AI starting to play a big role in front of the normal people. So we can see that if you can see the Kasparov, I'm not sure that you know the Kasparov. Kasparov was the first #1 at the time in the chess, right? So the computer chess and the program was built by the Deep Blue. We call it Deep Blue, right? So they tried in the February 96. They have the best player in the world for chess versus the Deep Blue from the AI for the AI chess, and it resulted that the Kasparov victorious 3 wins, 2 draw, and 1 loss. Next year, in March 97, Kasparov again. They have versus the Deeper Blue again. Previously was what? Deep Blue. But now they changed the name, Deeper Blue. Why is that? I'm telling you. First match won against the champion. at the end, it means that the deeper blue managed to success to win over the Kasparov. And at that time, we have 502 processors, 2 million chess positions per second. So you see, how do you think it works? You see that if you can win, just like the checkers or dumb previously, you can see that it doesn't mean that if you manage to win over the machine, you can win it over the time. Machines are very clever. They will learn in the past. It means that they will learn the move in the past, what is and what is not good. So this Kasparov have a limited of mind, limited of choice or strategy. Maybe he have 1,000 of moves, but if all the computer, the deep blue, the program already learned all the 1,000 moves, and then he left nothing. So that's why he started to do something. Okay. Fact on deep blue, all right, brute force computing power, massive parallel, RS3000, okay, at the time containing 120 megahertz processor, microprocessor. Just imagine we have now 5.6 gigahertz, even we have 16 billion transistor. It's much more than that. 20 years later from this date, almost 20 years. So I think that Kasparov cannot again, if he live, he cannot beat this computer forever. Enhanced with 400 purposes VLSI chess chips. Its chess playing program was written in C and run under the AI's operating system, capable of evaluating 200 million positions. In June 97, Deep Blue was the 259 most powerful computer according to the top 500 list, achieving 11.3 G-flops on the high-performance Limpec benchmark. Okay, all right, AI is the operating system from IBM that used the Unix. Okay, chess play defeated next game board. Okay, AlphaGo. I think you cannot. Okay, this is checkers. Can you hear this one?
I think it is the setting from Zoom. When you share screen, you need to check the share sound button, but it's okay.
It's okay. It's okay. I move forward. Okay, again, the AlphaGo. I make it fast now. Okay, I make it fast. Okay, the AI. Okay, because we have a bit time. Okay, I skip a little bit because we have another 10 minutes, right, before our finish time. All right, so I make it fast, important keywords. Okay, this is important keywords, important. Soft computing is the use of solution of the computational. Machine learning is the subfield of computers since they give computer ability to learn without explicit program. All right, pattern recognition. I will explain to this what is this and all these things. Data mining is used for unsupervised learning, pattern recognitions, and everything. Okay, I make it fast. Okay, so the vision of machine learning, right? Machine learning is the science of getting computers to act without being explicitly programmed. Okay, I mentioned recently, this is what the components of the machine learning, all right? Make it fast. Okay, this is a traditional program. We have the data and we have the input of the program and computer, and we have the output. Now we have the data and we have the output. We have the program. What this is all about? What is different between this? Okay, I'm telling you, the machine learning, what they say that the data and the output, it means that we given the data and we also given the output of it. Okay, for example, in class, if you want to study, right? If you want to study, I give you a book, and then later on, I give you the answer. Why I give you the answer? Because I will say that if you are doing this question, you will get this answer. I'm teaching you how to do that. That's actually what we done previously, right? And that's also how the machine are using that. That's what we call the data and the output, and that's how it treats the program. So it means that what is the program? The program is the AI, which will have whatever. When we have this, we're going to train the program to become better and better. Okay, so we have this machine learning, unsupervised, reinforcement, semi-supervised, and supervised. But I think supervised, we're not going to talk about it. We are going to talk about three things: unsupervised, reinforcement, and supervised. They have also the structured regression, multi-classification, and binary class. Okay, we will tell about it. Okay, this type of learning, unsupervised learning. Okay, what it means by unsupervised learning? Okay, we say that this is unsupervised learning. All right, so unsupervised learning is, we can say that high reliance on algorithm, raw data, large exposure of manual, okay, and relevant coding. But what is this all about? Okay, for example, it's very easy. Okay, for example, unsupervised learning is something that if I make some very simple example, if I give the students a book, I say that, okay, these topics, I give you these topics, right? For example, I give you this, can you learn the basic of the C programming? Which topics? I give you the topic. And the student managed to learn by itself. It go to the internet, they will learn, go to the library to find books, and they try to learn it from himself. So it means that without supervision from me, I'm not given any answer for it. I need him to discover by himself. That's what we call unsupervised learning. But how it is in the machine learning? So in machine learning, it means that we have the data, and the data will have the subset. I mean that we will have the algorithm. We create the algorithm, so we put it into the cluster. Okay, later on I will explain this in the next session. All right. So this is what the easiest way to understand the unsupervised learning is the student managed to learn by itself. Okay, by given specific, not very direct solution. Semi-supervised. Okay, I'm not this one. Reinforcement learning. What is the reinforcement learning? All right, algorithm is we see that the algorithm is continually trained by human. Input can be automatically once measured. Okay, reinforcement learning means that the machine is learning by reinforcement. We give some reward. For example, I have students. I will say that, okay, if you manage to answer this correct, I give you the answer. I give you the reward. I give you the money. So the students say, okay. So from the results, they will know, okay, this is right or wrong. For example, you know that I said previously the Deep Blue versus the Kasparov, how they won against Kasparov against chess. That's what we call reinforcement learning. But because why? Because they have a lot of moves, right? At the first of 1996, I showed you previously. If you see this one, in 1996, they managed to lose one loss, and they have only the Kasparov 3 wins. It means that Deep Blue lost managed to lose three games. So it means that they know, the system know what is wrong with it, what is moved in the past, right? So that's what we call the reinforcement. So the movement that makes it win, they will remember it. So that's how important the memory is. So they will learn a lot of steps, and in order they know if this step happens and what's going to be after that, because they learn about the past. That's what we call it the reinforcement. It means that we give the reward. Either we say that you are going to win, we praise it. So that's also we call it reinforcement. And the last one is going to be the supervised learning. What is the supervised? Just like in teacher in class, the teacher going to give you some examples, and also the teacher show you some solutions. So based on that, you might follow the answer. How about if there are a lot of questions after that? Based on these previous results, it's going to predict the future. That's what we call the supervised. Okay. Okay. So this is the how is the problem is solved using the machine learning. They only have 5 questions, and believe me, this is the only thing that the AI managed to do. No more than that. The first one is what? The first one is this A or B? For example, okay. For example, we have apple and orange. Is this apple or orange? They only have yes or no. So it's going to go to the classification algorithm. Is this weird? Something wrong happened. For example, so this is we call anomaly detection algorithm. How much or how many? It means that it's mathematics. It means that if I don't have how much money left in your pockets now, so we have the regression algorithm. Or for example, I want to predict how many how many Indonesia will get the profit, or company want to profit in 2020 based on 2021. So we call it regression algorithm. How is this organized? This is how is because it organized is unsupervised. Because why? They're using the clustering algorithm. I will tell you later on what is this. And the last one, the question is, what should I do next? This is going to be reinforcement learning. Okay, what should I do next? Means that they don't have the exact solution, but they will learn from, just like the Kasparov and the team. Okay, for the first one, the classification algorithm. Classification algorithm are used to classify records. For example, is it cold? Yes. What is the temperature right now? It's raining today. It's 36, 37, or 20. If you're in UK, it's going to be -10. So it is yes or no. It's going to be yes or no. So that you can use the algorithm. Okay. So we call it classification algorithm. Next, anomaly detection algorithm. What is anomaly? It is the pattern. Maybe the computer, you cannot give the exact answer, but you can give the pattern. For example, they have this pattern. They have 1, 2, 3, 4, 5, 6%, and the 7% is anomal. Because why? Because they have the red hair at the time. So for what's going to be the application for it? For example, in the credit card, right? Real life company, credit card company use this as an anomaly detection algorithm to detect any flag of transaction. It means that unusual transaction will be triggered and will tell you. If, for example, you have many transactions, something, but they are transactions from America at the time. So because of this algorithm, detect that, oh, this is unusual. So they will inform you. There are some things. There are some transactions from US. Is this from you? Usually bank do have this service and let you know if any problem. So we call it anomaly. Okay. So the third one is the clustering algorithm. This is unsupervised. What it means that it means separate data into group clusters and to ease the interpretation of data. For example, orange is they put all the fruits in the one color. They put all the fruits in the same size, or they put any fruits the same taste. So they have A, B, and C. This is the high mistake. By understanding how data is organized, and you can predict the behavior of particular event. Okay. So sorry, I have a little bit time. I make it fast. Regression algorithm. What is the regression algorithm? What will be the temperature of tomorrow, for example? Okay, the regression algorithm is playing with numbers. For example, how much discount can we give to particular persons? What's going to be the if you want to do the accountant, right? If you are an accountant, you want to audit some of the company's balance to balance the account, so you can use this regression algorithm. Okay, next, enforcement algorithm. What is this? This is why I said the system play chess previously. So they will learn about the past. You might beat at the first time, but later on they will learn and make sure that you are you can beat later on. So that's how it works. So this is the learning process. Is our examples. We have the real world, right? This is the servers measuring the real world data insert. We have the sensor or camera database. There's going to be your data as well, and that's going to email to the server. And the processing, we have the number of receptions, size of message, number of attachment. This is the big size of this AI. And we have the dimension of reductions, how the classifier works, model learning, qualification, regression, clustering, and distribution. And then we have the testing model to cross validation. We need to validate our result as well. That's why the model that's important. And then at the end of it, we have the analysis of the results. Okay. So we I think have 2 times left. I think we not enough to explain about this. These are examples. I make it fast. For example, this is the apples, this is tomatoes, and this is cow. And this is the machine learning framework, the output, the prediction function, and the image feature. Okay, the training given a set level examples and estimate the prediction by minimizing the prediction error on the training set. Okay, so this image training. We have the image results and the training levels, and to train it and learn the models examples. And we got the representation. This is the Apple, for example. Okay. There are a lot of classifiers to be chosen, SVM, neural network, and etc. Which is the best one? It's up to you. This is unsupervised. You give just the data. The weekly supervised. You give a little bit information. You see the person, and fully supervised in that you are giving more data to the computers. That's how they different. You can see the difference, right? First, supervised is less information, a lot of pictures with unclassified structure, a lot of different pictures. The second one, they start to have the structure. The first one is going to be human. The second going to be this animal. The third one is going to be the car, and the third one they going to classify more the differentiation between the man and the woman, and the animals was they're going to specific more, and the last one is going to be different what car type car. This is fully supervised. Okay, so I think it's time up. Then thank you very much. So I leave to the doctor. Thank you very much.
Thank you very much, Dr. Najib.
Yes.
That's a very thorough presentation from the history of AI until the machine learning task. Thank you very much. Okay, maybe Miss Vivi, you can share the screen. We will enter the second lecture session. And ladies and gentlemen, if you have any question for Dr. Najib, please hold it for now. You can write your question on the Google form, GLS Q&A, or maybe on the chat box, and then we will discuss it on the Q&A session. And then this is for the second lecture session from Dr. Khairul Najmy Abdul Rani from University Malaysia Perlis. He is also the UNIMAP Advanced Communication Engineering Center of Excellence Research Fellow, and Dr. Najmy received his bachelor degree in Electrical and Electronics Engineering from University of Missouri, Kansas, USA in 1996, and then he received his master degree in Information Technology from University Utara Malaysia in 2000. And then he received his PhD degree in Communication Engineering by Research in University Malaysia Perlis in 2015. Dr. Najmy research area includes antenna design, radio frequency and microwave, mobile communication, evolutionary algorithm, or evolutionary computation, and IoT. Please welcome the second speaker, Dr. Najmy. The time is yours.
Assalamualaikum and good evening. Can all of you hear me?
Waalaikumsalam. Yes, good evening.
I need to share my screen, right?
Excuse me, Dr. Najmy, your video is still off.
Hold on. Can you see my slide?
Yes.
Okay. So can I start now?
The camera that's still off.
The camera is off.
Yeah.
All right.
Okay. Thank you very much.
Okay. All right. Okay. Basically, okay. My name is Dr. Khairul Najmy Abdul Rani. I'm a lecturer in University Malaysia Perlis. As the same with Dr. Najib. Today I will give my lecture. In the topic is the swamp intelligence in communication engineering. Okay, I try to make it 40 minutes. Okay, it's quite a lot of slides, but I try to make it faster if possible. Right. Okay. Basically, what is a swamp intelligence? Okay. Swamp intelligence basically is a integral part, or is a part of artificial intelligence or AI. So it means that artificial intelligence is a very big field or big area. It consists a lot of components, including swamp intelligence, machine learning, and so on. Okay. Basically, as I will adopt or mimic the collective behavior of an organized group of animals, or organisms, or plants as they strive to survive, okay, or to get alive. So in this case, the self-adaptability, robustness, and searchability in S algorithm make it enable to solve complex non-linear problems. Okay. So in this case, I share you the taxonomy of optimization method. Okay, you can see here we have the search-based optimization. Okay, so under the search-based optimization, we have the global search method and also the local search method. Okay, under the global search method, we have the heuristic method, meta-heuristic methods, and also the random search method. And under the local search method, we have the gradient-based method and also the without gradient-based method. So under the meta-heuristic method, we can divide into two groups, which are the single social-based search and population-based search. So under single social-based search, we can have two examples of it, which are the simulated annealing and the table search. And also under the population-based search, we can classify into evolutionary algorithm, or shall we say evolutionary computation, and also the swap intelligence. So basically, there are many evolutionary algorithms that we can use for to solve optimization problem. The widely used or the most popular one is the genetic algorithms. Okay, and also for the swap intelligence, we also have various numbers of algorithms. Some examples are particle swap optimization, or PSO, and colony optimization, and so on, including the Kuku-search algorithm. Okay. So basically, SI is the population-based method that use meta-heuristic mechanisms in order to search for ideal or optimal solution of complex multi-dimensional problems that have a non-linear and non-convex dependent of design parameters. Okay. Basically, the term meta-heuristic come from two Greek words. Okay, the first one is the heuristic. This comes from the verb heuriscan, or meaning to find or to search, and also the suffix meta, which means the beyond or in an upper level. So meta-heuristic is a combination of these two words, to find or to search optimal solution beyond global search domain or local search domain. Okay, basically that's what it means. So similarly to evolution algorithm, or EA, swap intelligence is have a capability to deal with large number of optimization parameters through the stochastic search process. So what does it mean by stochastic optimization, or SO? Okay, SO methods are basically an optimization method that can generate and use or manipulate random variables in the formation of the optimization problem itself. For example, it can be a random objective function, or it can be a random constraint. Okay? So SI basically is better than the original gradient-based method or conventional numerical methods or techniques based on these four reasons. Okay. Number one, in SI, we don't need to do any assumption about the problem being optimized. So there is no assumption need to be done. Okay. Number two, SI has the capability to search for a high quality optimal solution by balancing between exploration and exploitation. So what does it mean by exploration and exploitation? Okay, exploration means that SI has the capability to find the solution at the local search domain, whereas exploitation, it means that SI has the capability to search for the solution at the global search domain. So there are two different scenarios there. Okay, one in local search domain, another one is in the other round. I'm sorry, the other round. Exploration in the global search domain, exploitation in the local search domain. Okay, so exploitation in the local search domain, right? So that was for number two. Number three reason is in SI we no need to get gradient information of the problem being optimized. So we can say that SI is a gradient-free method. Okay, and the last one, SI is simple and easy to be used in order for us to solve optimization problem. Okay. So basically, this is the taxonomy of SI algorithm. You can see here it comes from in general, it comes from bio-inspired algorithms. Sometimes people refer it as a nature-inspired algorithm. Okay, so under bio-inspired algorithms, we have evolution algorithm, swarm intelligence algorithm, and ecology algorithms. So under swarm intelligence, we can divide this swarm intelligence into 3 different eras where these algorithms being developed or introduced. It can be a swarm intelligence been introduced and developed before 2000, year 2000, or being introduced or developed within 2000 to 2010, and also after 2010 until today. Okay, so I list down some of the examples of SI algorithms, because there are numerous number of SI algorithms basically being developed, and you can find it from the internet and you can search through Google, okay, if you want. Okay, basically in SI algorithm were initially proposed in the early 1990s. Okay, it's about 30 years ago. Okay, which include end colony optimization (ACO) basically in 1992, and also the particle swarm optimization or PSO in 1995. It's the mid-90s. Okay, and during 2000 to 2010 or 2009, there are more SRM being proposed or being developed. Okay, for example, bacterial foraging optimization or BFO in 2002, artificial fish swarm or AFS in 2002, artificial bee colony or ABC algorithm in 2006, firefly algorithm or simply known as FA in 2008, and also the cuckoo search algorithm in 2009. So these are some examples of algorithm being developed during 2000 to 2009 or 2010. Okay, and then later on the more algorithm being developed rapidly. Okay, during 2010 till today. Okay, so I list down some of the example of the SI algorithm, which is a new generation. We shall say it's a new generation of SI algorithm, which include pigeon-inspired optimization or PIO in 2014, the Grey Wolf Optimizer or GWO in 2014, the Ant Lion Optimizer or ALO in 2015, Coyote Optimization Algorithm or COA in 2018, Butterfly Optimization Algorithm or BOA in 2018, Black Widow Optimization in 2019, Pathfinder Algorithm in 2019, Harris Hawk Optimization 2019, Simon Algorithm 2020. This is last year. Okay, Marine Predators Algorithm also in the last year 2020, and one of the most recent one is a Firebug Swarm Optimization or FSO in 2021. This is in this year. Okay. So now I just list down some of the swarm intelligence method that being applied basically in communication engineering. Okay, so number one, the use of artificial fish swarm. Okay, artificial fish swarm, AFS. Okay, artificial fish swarm was proposed. Okay, to optimize the power allocation for multiple input, multiple output, orthogonal frequency division multiplexing, or simply known as MIMO or FDM relay for underwater acoustic communications. So this one, there's a paper published in 2018. Okay, and then more research been done in the use of particle swarm optimization, or simply known as PSO, to minimize the number of base stations and optimize the base station placement in millimeter wave with the frequency of 28 and 38 gigahertz in the 5G network. Okay, this one paper published in 2019. Okay, and then the use of PSO also to improve routing schema with spatial clustering for heterogeneous wireless sensor network system 2019, and then the BLAF algorithm, simply known as DLA, to perform joint resource allocation and power control for device to device. So the one for D2D communication. This paper published in 2019. The use of fireworks algorithm combined with the partial transmit sequence for peak to average power ratio or PPR. Okay, reduction in orthogonal frequency division multiplexing or FDM with less computational complexity, also published in 2019. So these are some examples that we can see how swarm intelligence algorithm being proposed in order to solve optimization problem in communication engineering, right? Okay, for my case, I also use swarm intelligence method for my PhD study, and I extend my PhD study so that can get, solve potential problem in a more complex problem. Okay, so in this case, I propose what we call a modified search algorithm. Okay, by using the strength Pareto evolutionary algorithm, simply known as SPEA, multi-objective optimization technique. Then this hybridized MCS with SPA is precisely used for rectangular antenna array synthesis. And Alhamdulillah, I get published for this work in Springer Nature Scientific Report, which is an SIQ1 journal in 2017. Okay. So basically, in this work or in this research, I try to propose by incorporating three features or three parameters. Okay, the first one is the Rollingwood selection operator. Okay, basically, the Rollingwood selection operator is used in genetic algorithm in order to choose the initial population. But in cuckoo search, there's not been done before. So what in this case, I propose to use this Rollingwood selection operator in order to choose the initial hostness. So the initial hostness becomes the individuals or the populations that can give a better optimal result. Okay, that's the first one, the first parameter or the first feature. The second feature, I try to propose the adaptive initial weight. Okay, basically, in the original version of search, the initial weight is a constant value. It's a constant value. But in this my modified search, I try to make it become adaptive. Okay, make it become adaptive so that it can control the position exploration of the position-based hostness solution more effectively. And the third parameter, I introduce another dynamic discovery rate. Okay, in original version of search, the discovery also is a constant value, but in this modified version of search, I make it become dynamic. Okay, so that it can manage the fraction probability of finding the best hostness in 3D search space more efficiently. Okay, so three parameters here: Rollingwood selection operator, adaptive initial weight, and dynamic discovery rate. Okay, three extra parameters has been proposed in this my version of modified search. So beside that, I also hybridize the modified search with another swarm intelligence method, which is the particle swarm automation or PSO, and also the hill climbing stochastic technique, along with the standard strength Pareto evolutionary algorithm or known as SPA. Okay, and in this case, two new proposed methods being introduced, which are MCS, PSO, SPAA. Okay, the combination of MCS, PSO, and SPA, and also another one is the MCS, HC, SPAA. Okay, modified search, hill climbing, strength Pareto evolutionary algorithm. Okay, respectively. So basically, SPA is a well-known evolutionary algorithm, precisely used for multi-objective optimization. What does it mean by multi-objective optimization? It means that this optimizer can optimize more than one objective function or finite function at one time. That's why I choose SPA in this case. Okay. So now let us see how cuckoo search works. Okay, I try to make it to simplify this process because it's quite complex, but that's not that hard to understand. Okay, so basically, in cuckoo search, we want to generate a new solution. Okay, this new solution might be our new optimal solution. Okay, so in this case, we put the name as a x t+1. Okay, t+1 means the t is a iteration, +1 means the next one iteration. Okay, the cuckoo I. Okay, I here is individual. Okay, individual where the level flight integrated with additive weight w. Okay, so in this case, the xi of t+1 is equal to the w, the additive weight, plus multiply with the xit at the current iteration. Okay, t+1 is the next iteration. T is a current iteration plus alpha value. It can be any constant value. And t was multiplication with the levy flight. Okay, basically, a cuckoo bird is a bird that does not have its own nest. Yeah? So it practices what we call the brood parasitism behavior. What does it mean by brood parasitism behavior? It means that the cuckoo bird will search for a better nest, other birds' nest, so that it can lay its own egg into that particular host nest. Because it doesn't have its own nest, so it has to fly over to find other host bird nest so that it can lay its own egg. So in this case, the motion for the cuckoo to find the other bird host nest, we classify it as levy flight motion. Okay, levy flight motion. Okay, that's why the word levy there. Okay, so in this case, this is the equation in order to generate this solution. Okay, and then as remember just now I said I proposed the additive weight. Okay, so in original version the weight is a constant value, but in my modified version, I make it additive. Depends on the iteration number and also the maximum iteration number. So in this case, the additive weight is equal to the maximum weight minus bracket maximum weight subtracted by minimum weight, and this result time iteration number, and the whole result there divided by the maximum iteration number. Okay, so we can get the additive weight. So it means that at every iteration the weight will become different. Okay, and also for the proposed this dynamic discovery also, or the dynamic fraction probability. So in the original version, the fraction probability or PA is a constant value, but in my modified version, it also changed based on the iteration number and also the maximum iteration number. So in this case, same with the additive weight. My proposed this dynamic discovery is a PA equal to PA max, okay, the maximum fraction probability, minus the bracket maximum fraction probability subtracted with a minimum fraction probability, and this whole outcome the iteration number, and after that we divide it with the maximum iteration number. So we can say that the dynamic discovery will be changed based on the iteration number and also the maximum iteration number. So that's why it is dynamic, not static. And remember just now I said for my proposed algorithm, I will use 3 objective functions to be optimized simultaneously or at the same time. So in this case, 3 objective functions are primarily related to rectangular antenna array beamforming being used. The first one is a F1. In this case, what I do is I want to minimize the 1/, directivity, or in other words, I try to maximize the directivity of the main beam or the main loop. Okay, and then the F2, the second function, we minimize the array factor. So whenever we use a rectangular antenna array, we should deal with the antenna array factor. So in this case, I will minimize the antenna array factor. Okay, and then another one, the F3, I try to minimize the 1 minus dynamic ratio. Okay, so basically these are 3 inner function or objective function we use in this study. Okay, so F2 here, as mentioned earlier, is an antenna array factor. Okay, if you see in array factor on the right hand side, so this is on the right hand side, there's 2 terms. Okay, so we say, this is the first term. So for this first term, it deals with the average side loop level separation. Okay, average side loop level separation, and also the second term, it deals with the noise or interference mitigation. Okay, so two scenarios there in this one reflector equation. Okay, and for F3, basically the RR stands for dynamic ratio. Okay, because here I try to minimize 1/, dynamic ratio. So what is dynamic ratio? It is equal to absolute value of maximum excitation amplitude of current divided by minimum excitation amplitude of current. Okay, so this is how we calculate it. Okay, okay. Hopefully you can understand. I'm trying to see here. Okay, remember I said I use SPA, right? Strength Pareto evolution algorithm, right? So in this case, I just give some basic idea how Pareto optimality being the concept of a Pareto optimality. Okay, let's say we use this Pareto optimality for maximization problem. Okay, here is maximization problem using 2 decision vectors, which are A and B. So A here and B is the decision vectors subset of X. Okay, so basically there are two concepts here, or 2 that we need to know when we deal with the Pareto optimality. Okay, the first one is the A dominates B. Okay, A dominates B, and another one is A covers B. Okay, so when we do Pareto optimality, we need to know either we want A dominates B or A covers B. Okay. What do you mean by A dominate B? Okay, A and B are two decision vectors. Okay, so in this case, A dominate B means A must be greater than B at all time. Okay, at all time. If and only if I is the individual subset of 1 to n number of population, where FIA must be greater or equal to FIB, or maybe subset of J subset of 1 to n population, where F of J of A must greater than F of J of B. So if we fulfill these conditions, then we can say A dominates B. Okay, A covers B. Okay, A covers B means that A is greater or equal. Okay, is greater or equal. If and only if A greater than B or A equal to B. So if the A greater than B, we can say that A dominates B. If A greater or equal to B, we say this A covers B. So this is the basic concept of Pareto optimality. So in this case, why do we need to do Pareto optimality? Okay, in this case, we need to get the decision vectors. Okay, to get the decision vectors which are not dominated by any other decision vector in previous equation, or we call it non-dominated or Pareto optimal. So in this case, we want to find a non-dominated solution. What do you mean by non-dominated solution or Pareto optimal solution? It means that the solution that won't be biased either to any other function involved. Let's say if you want to compare, to do Pareto with Pareto optimality with two objective function at the same time. So we want that non-dominated solution does not bias either to F1 or F2 or maybe F3. So we want there should be a trade-off there. The solution should be have a trade-off between all these F1, F2, or F3 there. Okay, so that's why we the word non-dominated. Okay, we want that decision vector that is non-dominated by any other decision vector. Okay, so the family. Okay, sometimes the non-dominated solution or pattern can be more than one. Okay, it can be more than one. So we can come up with a Pareto optimal set. Okay, or simply set as a Pareto set or Pareto optimal fund, or simply set as a Pareto fund. So it means that Pareto set or Pareto fund can have more than one non-dominated solution. Okay, so I mentioned earlier, the non-dominated solutions, or in other words, a Pareto set or Pareto funds, will describe a surface with respect to the end objective. So it means that whatever value that we have on the Pareto fund or Pareto set, it will not bias to any other objective function that we try to do the Pareto optimality in this case. Okay. So in this example, I put in maximization, right? Okay. But if you want to do a minimization, you can say that A dominates B becomes A less than B. Okay. For a maximization problem, A dominates B means A greater than B. But for minimization, A dominates B, where A must equal to less than B at all time. Okay. So just switch this sign only. Okay. 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 So in my research, what I do is I will use my proposed algorithm, or shall we say multiple objective optimizers, to optimize the rectangular antenna arrays. Okay. So in this case, here is the structure of rectangular antenna array elements. So we have the x-axis, y-axis, and z-axis. Okay. So all the red dots here is the antenna element in rectangular dimension. So you can see here, along y-axis, we have the m number of antenna array element. Along the x-axis, we have the n number of antenna element. So this one m times n. Okay, why I multiply by 2? Because this is a symmetric antenna array, or rectangular antenna array. That's why I just multiply with 2. Okay, and then here we say we have two angles. Okay, for the first one at the xy plane, we have the azimuthal angle. So this is the azimuthal angle, and also for the zx plane or xz plane, we have the elevated angle. Okay, this one is r, is the radius for propagation, because we deal with the antenna. Okay, so basically in this case we are using this array factor because we are dealing with the rectangular antenna array. So this is the array factor equation. So you can see here with there's two summation being calculated here at the same time. One is from n from 1 to n, and another m 1 to m. Okay, remember we have the 1 to n, and then 1 to m. Okay, capital M. Okay. And this one deals with the average salute level suppression. This one deals with the noise or interference mitigation. Okay, so basically from this equation, there are some parameters that we can define. Like the K here is a calculated wave. Okay, calculated wave number. And then for the IM and IN is basically it's an excitation amplitude of current. VM and VM is basically it's excitation phase current or current phase. SM and SN basically is the location of antenna array element of both M and S array element on XY plane. Okay, right. So in this case, since I will be using the Pareto optimization, what I do is I will simulate by using MATLAB 10 evaluation of where every evaluation will be having 1,000 iteration will be running in order to do the Pareto of minimization. Okay, why do I do 10 evaluation? Because I want to get the consistency of result. It means that 10 times 1,000, I have 10,000 iteration being simulated. So hopefully my result will be consistent for every evaluation. Okay, and then in this case, I try to minimize two objective functions at the same time. So minimize fx equal to f1x and f2x. Okay, remember f1x will be dealing with a reflector. Okay, sorry, f1 will be dealing with the minimization of 1 over directivity, and another one f2 is a minimization of a reflector. Okay, so reflector here is since I'm using the rectangular antenna array, so this is the reflector equation. Okay, so I will minimize these two objectives at the same time. Okay, at the same time. So by using the Pareto trade-off, my result, non-delimitation shouldn't bias to either F1 or F2. Okay, because that's my objective to get a non-delimitation or Pareto set or Pareto front that are not biased to F1 or F2. Okay, so in this case, F1, F2 reach the optimal simultaneously, and the optimal solution will become as a non-delimited solution. Okay, so my optimal solution will be considered as a non-delimited solution. As I mentioned earlier, it shouldn't bias to either F1 or F2 at the same time. Okay, so basically, I had to test with the test function. We call it Zisler depth field. So ZDT, basically ZDT is a test function that is used precisely for multi-objective optimizer. So in this case, I use two types of ZDT function, ZDT1 and ZDT3. Okay, so this is the equation of ZDT1. You can see here that ZDT1 is F1 here and F2 here. So there's two functions there, and this is how F2 being generated. Okay, and then for ZDT3 also in the same domain of 0 to 1. Okay, same with the ZDT1. So you see here we have two positive functions, F1x and F2x. So F2x is this equation. Okay, so this is these are two test function. Basically to test my multi-objective optimizer, right? So this is the plot. Okay, you can see from this plot. So I have the fitness 1 there and fitness 2. So I tested 4 multi-objective optimizer, the original version of SPA. So in this case, the green dot. So this is the original version, meaning that there's no modification, there's no hybridization been done. This is the original version. Okay, and then the purple dot MCS SPA. This is a modified cuckoo search SPA, and the red dot the MCS HC SPA, the modified cuckoo search hill climbing SPA, and the cyan color or cyan dot MCS PSO SPA, modified cuckoo search PSO and particle optimization and SPA, the hybridization of 3 algorithms there. So from this plot, I put here two plot. This one is a 2 evaluation plot. Remember, I run 10 evaluation, right? But I just choose 2 out of 10 evaluation. So just to show that there is a consistency of my result. So you can see here, okay, the MCS PSO SPA has the best result. Because what? Because remember, I want to minimize and F1 and F2. So in this case, if you see here from this plot, this MCS PSO SPA have the smaller number of fitness 1 and smaller number of fitness 2 compared to other, right? Can you imagine that, or can you see that? Yes, so that's why this is Pareto front, the Pareto front. You can see these are all the non-delimited solution. Okay? So we name it a Pareto set or Pareto front. So in this case, this Pareto front for MCS PSO SPA lies in the most bottom part of this diagram. So it means that it has smaller number of fitness 1, and at the same time, smaller number of fitness 2 compared to other counterparts. Okay, and the same go for another evaluation also. You can see there is a consistency where the MCS SPA again have the smaller fitness 1 value and fitness 2 value compared to other counterparts. The worst algorithm is the SPA because we don't do any modification and any or hybridization. That's why it has the larger fitness 1 and F2 at the same time. Okay, so this one for ZDT1. Okay, before that, I need to teach you to give some basic understanding of box plot because I also tabulate my data in terms of box plot. Okay, for those who study statistics, you might know about this box plot. Okay, box plot basically is how we tabulate our data in a box like this here. We have the box here. So this is the middle line here. It's a median, not mean, median. The median data. Okay, and this dot, square dot here is a mean. Okay, so this is the box. We have the top box. The top, okay, here, top of the box is a 70th percentile of data, and the the bottom box is 25th percentile of data. Okay, between 25th percentile or to 75th percentile of data, we classify as interquartile range. So anything beside 25th to 75th percentile is the data is lies under interquartile range. Okay, anything outside this interquartile range because it's as outliers. Okay, you know, who study statistics might know about what I wanted to say here, outliers. So outliers here, okay, between 75 to 95, we have the straight line here, straight line, and then this line mentioned about the 95th percentile of data, and above that is the maximum value. Okay, so this is maximum value, and same goes for bottom part. So here we have a one straight line, and then here stop there is a 5th percentile data. So this one between 5th to 25th percentile data, this is a bottom outliers. Okay, this one the upper outliers, this one is bottom outliers, and then below than that is a minimum value. Okay, so this is how we understand the box plot. Okay, so in this case I tabulate my data, output result of my optimizer comparison in box plot. So you can see here this is MCS POSPA. It has a smaller number of median, smallest number of 25th percentile data, smallest number of 75th percentile data, smallest number of 5th percentile data, and smallest number of 95th percentile data. Okay, remember here. Because we are doing minimization, so we need the smallest number. Okay, the smallest the better. Okay, so goes to another version. So the MCS PSO plus with the smallest number of median, smallest number of 25th percentile, smallest number of 75th percentile compared to other counterparts. Okay, so for ZDT1. I also run on the ZDT3. So same, okay, ZDT3 also, you can see this MCS PSO have the smaller number of fitness 1 and fitness 2. This one for one version and another version as well. You can see here, still have the small number of F fitness 1 and F fitness 2, okay, compared to other counterparts. So there's a consistency of my result, regardless ZDT function, either ZDT1 or ZDT3. And the same goes for the box plot as well. For ZDT3, you can see the MCS PSO have the smaller number of median data, smaller number of 25th percentile data, smaller number of 75th percentile data, regardless of evaluation. Okay, so there's a consistency there. Okay, then one for ZDT function. Okay, remember I will apply this on my antenna array synthesis. So this is how we plot the normalized pattern, radiation pattern. So this one, okay, x-axis is a direction angle in degrees. The y-axis is the electric field in decibel. Okay, so we have the main lobe here. The main lobe is should have the higher value of electric field. In this case, 0 dB. So it means at 90 degree. So 90 degree is my my desired angle, desired direction of angle. So in this case, it has the highest or the peak value of electric field. Okay, other than that, we call it a side lobe. Okay, side lobe. Okay, this one the main lobe at 90 degree. Other than that, other direction angle is side lobe. So I use a Dove Schultz window, means that all the side lobe must be equally, theoretically, should have almost similar reading of electric field. So I magnify the main lobe here. You can see here, this is the cyan color, right? Cyan color stands for MCS SPA. It has the highest directivity, or in other words, smaller half power beamwidth. That's why I can hear the nearer to the 90 degree, the better. Okay, the nearer to the 90 degree, the better, because we need higher directivity at 90 degree. Okay, so here MCS SPA has the highest directivity, and at the same time, smallest half power beamwidth or 3dB bandwidth compared to other optimizer. Okay, and also this is the side lobe. Okay, I try to magnify the side lobe. You can see the cyan has the best side lobe level suppression, meaning that it has smaller value of side lobe level reading compared to other. And you can see here. Okay, the lower the side lobe, the better. Okay, the lower the side lobe, the better. Okay, and then this one in 3D plot. So you can see here the MCS PSO SPA have the smaller half power beamwidth, and also the higher directivity, and also the lower sublobe separation. Okay, and then this is how we optimize my antenna array element. Okay, basically in conventional antenna array element, we put it at 0.5 lambda. Okay, so here, because since I'm using 20 element, so I just put 10, because 2 times m times n array element. So here for element 1 is should be arise around at plus minus 0.5 at lambda in the position. So after optimize it using the algorithm, you can see through SFA it fluctuates to this new position, and so for the MCS PSO SPA as well. So you can see by using MCS PSO SPA, the fluctuations have the greatest fluctuation. Okay, because it fluctuates up to 0.8026 just for element 1. Okay, compared to other, just fluctuate a little bit compared to the conventional array. Same goes for other antenna element. Okay, and then this is the associated amplitude of current. By using MCS PSO SPA, it has the greatest fluctuation compared to other antenna element, other optimizer. And then this is in 3D plot. Okay, this one for associated current phase, SPA also had the greatest fluctuation. So in 2D and also in the 3D. And then I also test on the antenna array under uniform window with predefined noise. Okay, uniform window means what? Means all the side lobe level must be smaller as is further away from the 90 degree. Because my 90 degree is my desired angle. So as we further away from 90 degree, the side level must be smaller on the right hand side, and same goes for the right hand side, left hand side. Okay. So in this case, I put 4 predefined noise. What I mean predefined noise means that I put 4 interference at this 4 angle: 55 degrees, 60 degrees, 180 degrees, and 135 degrees. Means that we interference here, you need to suppress it at the lowest possible value of electric field. Okay. So okay, I magnify the main lobe. Still, my MCS PSO SPA has the smaller half power beamwidth and also higher directivity compared to other optimizers. Okay, for side lobe level separation also, it has a better side lobe level separation compared to other optimizer, because smaller number of electric field in dB compared to other, right? And also this one for the non-multiplication, I succeeded to suppress it at the minimum possible value, which is minus 88.73 at 55 degrees. So it means good, because we need to make sure all the noise is suppressed at the lowest minimum possible value. Okay, because noise is like an interference. Okay, and this one is in 3D, and also this is the element collocation. Okay, this one in conventional at 0.5 lambda, half lambda for every antenna element, plus minus. And then this one, you can see the MCS PSO SPA have the largest fluctuation compared to other optimizer. And all antenna element, you can see from antenna element 1, and element 2, element 3, element 4, and so on up to 10. It has the largest fluctuation compared to other. Okay, because we compared with respect to the conventional antenna array. Okay, and this one the amplitude. Okay, as amplitude, you can see the fluctuation. MCS PSO SPA has the greatest fluctuation in 2D and in 3D. For association current phase also, largest fluctuation, MCS PSO SPA in 2D and also in 3D. Okay, basically, the introduction of some value-added optimization attribute, which are Rollingwood selection operator, additive weight, and the dynamic discovery, has supported the proposed MCS PSO SPA to outperform other compatible rivals, including conventional antenna arrays, in detecting related pattern with the highest directivity. Okay, this is the result. The lowest average level separation, the narrowest or the smallest half power beamwidth or 3 dB beamwidth, and also the best predefined noise or interference mitigation respectively. Okay. So in the future, okay, we besides using SPA, we can also use other parental optimal methods. We can hybridize the cuckoo with other parental optimal methods such as the non-delimited sorting genetic algorithm (NSGA), the vector evaluated genetic algorithm or VEGA, and also the niche parental genetic algorithm (MPGA). So in my research, I use SPA, parental algorithm, but you can also use other parental optimal methods if you want to look for further research for the study. And besides that, you can also use on other complex antenna array geometry. Because in my study, I use a rectangular antenna array. Besides that, you can also use, for example, concentric circular antenna array, cylindrical antenna array, spherical antenna array, with large number of elements. In my study, I use 20 symmetric antenna elements. But you can try to use this for the study. You can use it for large number of antenna elements that is asymmetric or non-uniform. Okay. So we are using this one only suitable for MIMO. Okay. For MIMO, we need large number of antenna array elements. Right? For MIMO, it's okay, 20 elements, but for MIMO, I think more than that. Okay. And then besides using the uniform window and dwarf distribution window, we can also use other different signal processing window. See the Turkey, Kaiser, Blackman, Lanzos, Hamming, Poisson. These are all other different signal processing window. So I just list down some of the current research being done by my postgraduate student. So okay, the first one, the student used hybrid modified method of sine cosine algorithm with cuckoo algorithm for radar communication system, and she just recently graduated in 2021 and managed to publish 2 ISI Q2 publication. Alhamdulillah. And then another student, this one from Pakistan, still in the initial stage. She's doing research on enhanced cuckoo algorithm using fitness predictor optimizer for early breast cancer detection using microwave tomography modeling. Okay. So hopefully she can manage to do this. Okay. This one I get from grant from Malaysian government grant. And then for master student, doing the modified black widow optimization for symmetric linear antenna array synthesis. And the last one is one from Indonesia, from Medan. She's using intelligent model system for standardization of NAMAT serial processing. Recently, she said she wants to change this topic. She also wants to use the swarm intelligent method. Okay. Because before this, she wants to apply neurofuzzy, but I don't know, maybe she feels quite hard for her. So she said she plans to change to swarm intelligent method. Okay. So these are all the references for this presentation. Okay, I think that's all. Thank you. Terima kasih. Any question? Ada beberapa soalan? And see you again. Ketemu lagi. Okay, thank you.
Thank you very much, Dr. Najmy, for sharing your experience and expertise regarding this topic. The explanation is very compact, and congratulations on your publication that was published in Q1 journal, and then also for your postgraduate students. They are both amazing. Okay, now we will enter the question and answer session. I will invite the participants. If you want to ask a question to Dr. Najib and Dr. Najmy directly, you can use the raise hand button. In addition, participants can also ask questions via chat box or by using the Google form provided by the committee. Okay, while waiting if there is any participant who want to. Oh, okay. Thank you very much, Ms. Nur Aziza, please.
Okay, test. Am I audible?
Okay, yes.
All right, first of all, thank you so much for the opportunity. My name is Narjiza and I'm from informatics department in ITS, and I would like to ask Professor Najib about regard the AI in the future. So actually my question is some kind of a very common question amongst the student about AI in the future, because you know, despite all the advantage that AI has given, such as the machine learning and things that, and also AI has helped us to do the boring work, the dangerous work. But I actually wondering, are our country, such as Malaysian or maybe Indonesian, is ready for AI to be applied widely? Because you know, like the global population is also growth very fast, right? And that may impact the AI disadvantage about among us, because you know, like AI may increase the unemployment between around the humans. So I was wondering, are Malaysian or maybe Indonesian already for AI and machine learning to be applied widely. So yeah, that's all from me. I hope you understand my question. Thank you.
Yeah, thank you, Nur Aziza, for the good question. Yeah, actually, this is what we call the opportunities, right? So, for example, I said that if I'm not mistaken, the question is there are some questions you ask, the Malaysians in Malaysia or Indonesia ready for that, right? First question is that. So, actually, in Malaysia, I'm not sure in Indonesia, but in Malaysia, actually, we already moved to IR 4.0, where most of us, I mean, there are a lot of sectors have been focused on, especially in agriculture, health, even in many manufacturing in the factory. They are all moved to the IR 4.0 now. Even the universities, they are the students started to learn about this AI, and most of us been introduced in the subjects. There are some universities tend to do that. All right. So what are benefits to the people if so they are not being employed? Okay. So that's what we call the opportunities. Okay. So as you can imagine, right? All right. This AI might improve the human life in terms of improving their business. For example, I didn't have much time to share the videos, but for example, what can I say is how we look at the opportunities actually, right? Okay, we might lose some of this employment, but we can see another opportunities. For example, this Facebook, right? We know that everyone are using the Facebook, and the Facebook are using our locations. They're not only using our locations, but they're also using our data, right? For example, marketing. They know what we are going to find. It. We just find I want to buy a bicycle, for example, or I want to find food, for example. So every time I put it down when I keep searching on the internet, so this will alert the AI, right, to show the advertisement at the Facebook, so that we have the marketing nearby. That what are you looking at? That's why sometimes the advertisement is based on what you're searching for, right? What does it mean? It means that there's opportunity on the market there. So if you don't want to be lost, you need to learn about AI for your own benefits. You can learn to start up the business. Okay, I'm telling you now. Yesterday, I've been explained by one of our representation from our minister, right? Malaysia now, they are open for the startup company. What is a startup company? So this is what the system play a part, right? So they need to create the employment. So just imagine if a lot of people learn about this AI and know this benefit AI. He doesn't need to know this AI. He just need to employ. Can you hear me? Yes. Can you hear me? Yeah. Okay. So what it is everyone tend to use this AI to build a startup company, for example, or use that to start up the company. So they will have more employment, and this unemployed person will be reduced because of that. And at one sector, they need to use the machine or AI to improve the efficiency of the work. So the benefits will come to the company, and the people will pay more tax to the government, right? So when the government become richer, so this money will come back to the people. You see? So the other way around, and the people will look at, okay, this company successfully benefits by the AI. So a lot of people are trying to copy at the same time. These are the role model. So people are trying to use this model to enhance their business. Indonesia, a lot have 100 million of people. Just imagine that. I am amazed with that. You know what are the benefit of Indonesian? When I saw in the YouTube, right? Every video made by Indonesian are reviewed by millions of people easily. we Malaysians only viewed 1,000. You know, it's very difficult. Even the video of sleep people, they just sleep. Man, they got millions. Oh, I amazed. It's not. And I heard about the mukbang. I'm sorry, I don't know what's the term. They eat a lot of foods and they have millions. And you see this one, they also what? They also get benefits of this AI, the Google, YouTube, and these industries. You know, so in future there's a lot of opportunity. So the people just want to. If you want to help the poor in Indonesia, poor people in Indonesia, you just need them to upload the video, and then they will be paid by the Google itself, right? Just imagine that, because you guys, Indonesia, did a very good job in terms of corporations. So if people are aware of this, then you have been paid easily for the money. I don't think you have the employment factors. And I heard that the Indonesia now have the Tesla, right? Tesla, some big companies coming to the Indonesia now. Why not you take the opportunity to learn how it develops? Don't think how can I work with Tesla, but think how I'm going to be like Tesla. So if you're going big, I believe that you are dreaming big. Even though you are not achieving as what Tesla are achieving, but you are close to it. Remember, Indonesia have 100 millions of people, as not big as China, but I believe if they are managed to work hard, they're going to be as China later on. Okay, so believe in me, if you think it positively, you get a positive thing. But if you saw it negatively, you will turn another way around. Okay, I hope that you answer your question. Thank
Yes, that's really answering, sir. Thank you so much.
you. Yeah, you're welcome.
Thank you very much, Ms. Nur Azizah, for asking, and thank you very much, Dr. Najib, for give the insightful answer. Actually, the question by Ms. Azizah is similar with the question asked by Mr. Nisfu Asrulsani from the Department of Information System ITS. Okay, for the next question, is there any one of the participants that want to ask directly to the speakers? Okay, while waiting for the participant, maybe I will read the question asked from the asked by the Google form. The first question is actually from Mr. Asrulsani, Nisfu Asrulsani, and the second is by Mrs. Febi Artwodini from Electrical Engineering ITS. She asked to Professor Najib. Okay, to create some novelties in our research, we often conduct experiment by mixing and matching some technique. Then we will prove the best result than other previous research. Different data will generate different results. Thus, sometimes Mrs. Febi often feel overthinking that the technique of AI is just for trial and error. She feels that the powerful of AI lies on the embedded system. As we all know and often find, some applications placed in hardware are robust and truly powerful. For example, it's like smart car, robot, smart assistant, etc. Is the power of AI truly actualized for the embedded systems rather than investigating the data itself? Please share some examples based on your experience, Dr. Najib. Thank you.
Can I have the question so can read it again?
Okay.
No, I cannot
Is
read.
the power of AI truly actualized for the embedded system rather than investigating the data? Because Mrs. Febi thinks that for the data, for the research that involving the data, we only do trial and error. So the power of AI is not really actualized in data investigation.
Okay. I think this is from a postgraduate student. Maybe Dr. Najmy can help me on the answering the question later on. Okay. It's a good question actually about the novelties. Some people say novelties, right? Novelties. There are certain things that we can divide into. First one is that we're going to change the code. I mean, the AI itself. That's going to be the novels. Same with other engineering methods as well. Means that we change the theoretical itself. So some people will say, there are two people talking about this. Some people say that novelties, especially PhD, they need to try. They need to start from the equations, from the theoretical itself, rather than you have these tools, you're using it and you claim novelties. Same for other things. For other things, they are using the design. They just, for example, for the antennas, they design the antenna, they get novelties. Okay, actually, try and error. If you say to me, I heard that one of the Nobel winners, right, prize winners, I'm not sure, I think the Japanese, I can't remember the name. One question been asked to him: how you get this work done? I mean, how you going to achieve this? You know what's his answer? He said, just say that try and error. Try and error. Yes, it's try and error. And the second one, the second Nobel Prize winner, they said again, you know, the day that he been told that he's been the winner of this Nobel Prize, one day prior to that, right? His proposal to the grant has been rejected. He sent the proposal into the two. Number one, the same proposal want to go to the grant. The second, the proposal changed to the paper. The work done changed to the paper and some contributions. And this proposal has been rejected by the grant. They said that there is not enough novelties. And then the next day, he's been told that he's the prize winner of the Nobel. You see, the different people thinking it different. I can say, might be today you get the review from the journals, a reviewer from the journals, they might reject your papers. And then, because maybe I'm not sure how they look at it, but some people will value you directly. Okay, so for me, it's the data, of course, is not a novelty. But of course, if you are comparing with the results and you get better results from the previous, what are the benefits of we are getting this publication? Is to share the information, right? For example, okay, we have the crash situations now in the AI for the COVID-19. So even I use the same concept, but I want to tell the world that this result is significant. And it will help people in combating this COVID-19. I don't care how much value my paper is, but the most important thing, it's been acknowledged by the people around the world. You see, that's the first intent for publications. So you seeing that, then I don't think that any publication, any good result should be publishable. And there is no such thing that is called rubbish. I think Dr. Najmy can share with me. I think he got many experience than me. Thanks.
Okay. Yeah. What I see here, okay, when we deal with the artificial intelligence, okay, there's two perspectives. This is my perspective. Okay, the first one is okay, like Dr. Najib said, you can use AI in order to save the world. For example, like COVID-19 fighting, right? Because the artificial intelligence method can be as the effective tool, so that you can do some good prediction, and also from that we can combat the COVID-19 virus. Then what is I can say that there's more on the innovation. Okay, so in this case, innovation for me does not need novelty. You can use whatever method, AI method. It can be short intelligence method. It can be machine learning. It can be neural network or anything related to AI in order to solve our daily life problem. Okay, that one is an innovation. Okay, for postgraduate student, okay, you need more than that. Okay, not just innovation, but novelty. What do you mean by novelty? What do you say about novelty? Okay, novelty means anything that you can contribute to the body of the knowledge, right? For example, if you are using let's say for my case, I'm using Google search. Okay, Google search basically is original version being developed by someone else, right? We can use that to solve your own problem, your own automation problem. But in this case, to get PhD or master degree in research, you need to come up with another version, your own version of Google search. You can do that either you modify it or enhance it so that it can be better compared to the original version, or you can hybridize it with other artificial intelligence method. And make sure that there's no other people who did it before. And the result must be validated. Means that they had better solution compared to other counterparts. Okay, so there's two different view here. Okay, for innovation, it's okay. You can just use whatever method, artificial intelligence method that you want, and then you can share to the public, to the world, and see that this is the good tools that you can use to solve complex problem or multidimensional problem. But for PhD and master, it is not enough. It's not enough because people will say, "Oh, this method has been used before, has been published by someone else. So what's your contribution? You need to contribute something to that particular method. So how to do that? So it comes to the contribution to the knowledge or the novelty. So you need to do some enhancement on that particular artificial intelligence method. It can be done by adding some certain features or parameters, or it can be done through hybridization with other algorithms. And in this case, you need to enhance it first. Then you can hybridize it. You cannot just simply hybridize with the original version to original version of algorithm, and then you say this is my own version. No, because it still can be considered as other people's contribution, not your own contribution. So you need to modify first. You modify first, and then you hybridize. Then you get the novelty. Okay, make sure that you have the problem statement here. So, for example, why do you want to modify that particular algorithm? Let's say you come up with one problem statement here. I want to solve a local threat problem, for example. Okay, local threat problem means that the original version of algorithm stuck at the local search domain. It cannot have the capability to find the global search domain. It means that it has a good exploitation but poor exploration. So by modifying it, you might solve this problem where the algorithm can search beyond. Meta heuristic and it search beyond to the global search domain. So you can solve this local threat problem. So this is example of a PhD study. Okay. I hope you can understand what I'm trying to say here. Okay? Thank you.
Thank you very much, Dr. Najib and Dr. Najmy. I hope it answers your question, Mrs. Fabi. Okay, actually the answer from Dr. Najmy, I want to ask a question to Dr. Najmy about how do you get inspiration to develop a new method to combine and modify a state-of-the-art method and then propose a novelty from it. But maybe actually it's already answered by Dr. Najmy that you need to do this. First, you need to find the problem. What's the problem in the state-of-the-art method, and then you need to do some research regarding how to solve this problem, and then try to find whether whether what you want to propose is already proposed before or not. Is that correct, Dr. Najmy?
Yes, that's correct. Yeah, that's correct. Because of course, we need to get the problem statement first, meaning that you have to find what's the limitation of the existing algorithms, so that you can improve it, so that it can be much better in terms of finding the optimal solution. Yeah, of course.
Okay, thank you very much. Actually, I'm curious, Dr. Najib or maybe Dr. Najmy have experienced something like you found something like you already found a novelty, and then when you try and to do the experiment, the result is worse than the state-of-the-art method. Have you ever experienced it before, and how do you react to that problem? Thank you.
I think it's normal. It's normal because sometimes how to say, you like Dr. Najib said, this is a try and error. you need to do some try and errors, and then from that you learn from your mistake. Try to come up, try to improve, try to make something, how to say, put some certain features or parameters that they think can improve the existing algorithm. So it does not 100% say that, okay, I plan to do this and you can get the result. No, there's no such thing, because you're doing research, right? Research is an uncertainty, right? The result is an uncertainty. So yeah, of course, it's a normal thing. It's normal thing. When you do some modification, you get worse than that. So try to learn. Try to read more paper. And try to search for more paper. See how do they propose? How do they do the modification, application? and then from that you try to imitate in your own algorithm. But for sure, make sure that there are no other people been done before, because you need novelty, right? Yeah. So that's my answer.
Okay, good answer by Dr. Najmy. Okay, one more thing. I used to sometimes to face this problem as well. Sometimes when we simulate it, right, we have very good results, and then when we're doing the experiment, it's not as what we expecting. It's actually normal in my first year, second year during my PhD. So with that the thing is, I think in the real situation, in simulation, is something that different. We need to understand the real environment that affects the results sometimes. So that's I'm sure, I believe that the simulations or the work that you've done might be correct if you've done it supervised. That's why if you are doing the correct method, you are producing a good result. Okay, for example, you are being monitored by your supervisor and your methods correct. But the only thing, when you do the experiment, it should have different results. What if I'm facing this one, right? Well, firstly, I'm going to refer to my superior or my colleagues. I will explain to them what happened during my experiment. And then we're going to find the answer. Might be it's wrong during the experiment. You might wrong somewhere else that you need to properly define it. So you need to read a lot of papers regarding the experiment and how it's been done. And else, if not sure about it, just email the paper's authors, the corresponding authors, or even the one who expert on it, and you try to learn about it. Getting a good result is just half weight on it. I believe that if you have the courage and you believe in yourself, you will learn towards it. This journey, right? This journey is not about PhD itself only. But if you are publishing in high impact journals, they are not saying that, okay, you get a good results, you're getting this verified, but how about the theoretical? Can you explain more about the theoretical, how you get it? So it means that if you want to publish in high impacts, right, you need to have these fundamentals and also these experimental results that they are tally. So this is how we are working on, especially in working on high impact journals. So we are doing it how this theoretical works, and you need to tally with the experiment works. And this theoretical works, if you are novel on it, I believe that will impact more on it. Okay, so it believes on the theoretical, and that's why strong fundamental is very essential for your studies. Okay.
Thank you very much for the answer, Dr. Najmy and Dr. Najib. Yeah, and thank you very much for the tips to do research, a good research. Okay, because we have a limited time, maybe some of you want to ask a question, the last question to the speakers. Okay, if there is no more question, maybe I will conclude this today's event. Thank you very much, Dr. Najmy and Dr. Najib. Yeah. Before we end it, I want to make a maybe simple summary about today's topic. Yeah, actually, Dr. Najmy and Dr. Najib already give us many suggestions, tips, and insight about AI. But yeah, I want to highlight some points. Artificial intelligence and all of the methods and technologies associated with it are constantly evolving, and this cannot be contained. There are many advantages that we can obtain from this development if we have positive perspective. Yeah, and especially this development can be used for the industry and infrastructure. So we don't need to be afraid of the negative impacts that may occur because of artificial intelligence. Yeah, we need to minimize those negative impact. And for that, we need to always improve ourselves to utilize the benefits of AI. And then also in the field of research, also currently technological development and methodological development make it seem as if it is difficult to get a novelty, but by researching the existing problem and also conducting many literature studies, reviews, we can certainly find a significant novelty. Okay, thank you very much for our honored speakers, Dr. Najmy and Dr. Najib. I will like to pass it back to our Master of Ceremony, Miss Vivi. Would you?
Okay, thank you so much to our speaker today, Associate Professor Muhammad Najib, and also Dr. Khairul Najmy for the excellent lecture. And thank you so much to Dr. Aras Maya for conducting this amazing session. Please give applause to our speaker and moderator by using the Zoom reaction feature. Furthermore, we would like to present a certificate awarding to our speaker and also our moderator today. This is the certificate presented to Associate Professor Muhammad Najib. Thank you so much, Professor, for this amazing lecture. And next, the certificate presented to Dr. Khairul Najmy Abdul Rani. Thank you so much, Dr. Khairul Najmy, for this amazing lecture. And the certificate presented to Dr. Rarasmaya Indraswari. Thank you so much, Dr. Raras, for conducting this amazing lecture. Once again, thank you very much to Associate Professor Muhammad Najib and Dr. Khairul for your availability on today's guest lecture series. We believe that your lecture will be useful for all the participants. Now, before we end our lecture today, we invite all the participants as well as the honorable speaker and moderator to take a group photo. To the all participants, please turn on your camera. Okay, as we have 3 slides, please keep smiling until we finish the photo session. Okay, I'm going to take a group photo for the first slide. Okay, ready? I'm going to count 1, 2, 3 and smile. Okay, and then the next slide. 1, 2, 3 and smile. The last slide. 1, 2, 3 and smile. Now we have finished the group photo. Then for the participant, please fill the feedback form through the link bit.ly/feedback/GLS that you can also see on the Zoom chat room. The deadline for the filling the feedback form is 1 hour after we finish the session. We want to remind you the participant who will get the stamp for it are the participants who came on time, join this event until the end of the event, and also fill the feedback form. Finally, we have reached the end to this guest lecture series, and we sincerely apologize for any mistake we have made in presenting as master of ceremony and committee. Thank you so much to the honorable speaker and moderator, all the participants for the attention and comprehension. We hope to see you again in another event. You can see right now on the screen that next week we have GLS on SDGs with Associate Professor Sarifah Redia Sarif with the title Modeling Small-Scale Process for Sustainability, and along with Mr. Raven Tabiogan for Summer State University with the Technopanel Future World for Innovation, Service, and Business. And the next stream we will have Associate Professor Bram Entong from Section University of Applied Science with the title The Adoption of Energy Technique and Measure in Residential Building as Multidisciplinary Perspective, along with Dr. Zakir Tarmidi from University Technology Malaysia with the title Social Sustainable Based on the Location-Based Indicator for Residential Area. Don't forget to follow our social media on Instagram at ITS International Office and keep updated of our program. So this is the end of today's guest lecture series. Good evening and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to our speakers and the committee and also all of the participants.
Thank you so much to Ibu Raras and Associate Prof. And Prof. Dr. Najmy and all the participants. Okay, allow me, could you, Miss Rani, could you please to help end the session?
Okay, thank you, Miss Vivi. Allow me to end this session at 5, 4, 3, 2, 1. Goodbye, everyone, and see you next